So this is the completed Hyperlight Drifter sword. It charges just from standard USB battery. It can charge from like a computer or really anything that you can plug a USB cable into. It can function while it charges, although it might get hot, so I like to unplug it before I use it. Sadly, my build, the LEDs only go up to here because I didn't measure properly and I burned quite a few LEDs, so make sure when you do intend to build this, you get at least a meter of LEDs and you cut it to length, as one of the last things you do. It goes together pretty simply. Everything just is designed to slide together. I recommend you build the electronics package in the hilt, and as you can see, I broke it here and here so I could fit the electronics package in. That was just poor planning. But what you do is you put the electronics package in the hilt, then you push the LEDs through the first section, and then push them through section by section. That worked pretty nicely for my build. The primary power switch, which in the schematic is labeled the primary power switch in the schematic is labeled S1 and is attached to the voltages. It is put in the bottom, and then the S2 button is put right there. You can change the size of this for whatever you need, but when you flip the switch, it flashes green once to tell you that it's on and it successfully started up, and then if you click your button, just as a brief click, the sword will light up blue, and it will retract when you click again, and then if you do a long click, it will flash white, and when you let go, it glows red. That's to simulate him doing a charged attack, and it can do that at any state, whether it's open or whether it's closed or open. It'll work either way, and it will always wait for you to release it. I found you can get about 15 to 30 minutes from a 1 hour charge, and depending on what kind of charging circuit you use in the hilt, it can vary. I used the old core of some old Bluetooth headphones, and it seemed to work pretty well. This material was originally black. I had to spray paint it red. I don't recommend that. I recommend if you want to make that red, you buy red material. And now there are some notes I have to go over for the code.
Okay, so in the code, there are a few things to note. The first is, the way I have it set up right now is the LED pin is on pin 9. That is the signal pin to the LEDs. I've given it 100 pixels. That's just an arbitrary number. It doesn't matter how many you do there, as long as it is greater than or equal to however many LEDs you're using. I just set it to 100 because during testing I needed to make sure that however many I was using would work, and I was just too lazy to set it back. And by the time I knew how many LEDs I was using, the sword was put together and programming would be impossible. The T pin is the trigger button. It's whatever is used to extend and retract the hilt. It is on pin 6. And so you're also having to use the Adafruit Neopixel LED library, which you can get that just by doing Manage Libraries. Give it a second. My computer is not the best. And just search Adafruit Neopixels. And I use this one. And you can tell it's the correct one because when you go to your examples, you have Adafruit Neopixel, and it has all of these examples. And now I'm going to go through what the code does, just so that you can understand it. This variable is needed just to help identify the timings of the system, and I'm not sure if it has to be a short variable, but that's what I've gotten it to work with. So on startup, it starts by initializing the LEDs. It shows them as clear, and then it sets the brightness to 100%, and then it takes the pin that you decided as the switch, sets it as your input, and then it fills the entire strip with a red value of 0, green of 50, blue value of 0. So just that's it lighting up green. It updates it. It pauses for a tenth of a second. Then it clears it, and then it updates it again. Then it goes into the main loop. It clears the LEDs, and then it waits. And then it waits because it says while this pin is red is low, it just delays 1 and X equals 1. That basically means until you click the switch, just sit there for a bit. And then when that is false, basically when you click the button, it sets the pixel color of letter I, or variable I, to this value, which is the RGB value for the blade, and it updates it. It pauses for 2 milliseconds, and then it loops it again until I is greater than 100. And then this commented outline I used for testing. It is just a light red or a dark red color, so that like I wasn't pulling too much power from my laptop. Otherwise, it would cause my laptop to turn off the USB port because it was overloading it. You don't have to use this, but I recommend while you test the code to make sure you did all the wiring correctly, that you just uncomment that and comment that. But it doesn't matter. It'll still work if you use it like that. Then it sets X to 1, pauses again, and then it waits for that pin to go low, or it waits for the pin to go high again, which is basically to help prevent debounce. And then while it's waiting, or while you are still holding the button down, it increases X by a little bit. And then it waits for that pin to go high, or during this section, it is while you are holding the button down and X is less than or equal to 200, it is increasing X by 1 every millisecond. And once X is greater than or equal to 200, it jumps out of that loop, and then it will, and then this is the code that flashes it. So it turns it off, it updates it, it pauses for 50 milliseconds, it then lights it up blue, it then updates it, clears it, updates it, goes blue again, updates it, and then goes white, and then updates it, and then it waits for you to release the button. Then and this is just to help keep this thing going steady, because no matter what, if you had when you release the button at this point, only if X is greater than 200 or greater than 190 will it go. If you have only held it down for a tenth of a second, which is like just a standard small click, it will skip this, and this. It will, but if you've held it down for that amount of time, it will update the color so that it goes red, and then it will wait for half a second. And then no matter what, no matter how it goes, it will then retract the blade, and then wait for you to click it. I hope that makes sense. If the code works, there's really no reason for you to mess with it. Although, if you use the Arduino cores that I linked on Amazon, this is the important bit. If you use those cores I linked on Amazon, they are the, well, I'm just going to say there's a reason that they're cheaper than if you bought them from Adafruit. And so you have to tell it that you're using an Arduino Nano, which is normal, but you have to tell it to use the AT Mega 328P old bootloader. it will not work if you use the recent bootloader or the 168 board. And then whatever programmer works here works. Right now there's nothing connected, but make sure you have the old bootloader selected. And the Adafruit pixels I'm using are the Neo GRB 800 kilohertz. That will be different depending on what you get. And yeah, I hope that makes sense. And feel free to leave a comment with any questions.